Good afternoon and welcome. My name is Tom Carpenter and I'm the CTO here at CWNP. So we're going to go ahead and get started today with this topic, which is a foundations topic. However, these foundational concepts are absolutely essential to implementing an effective wireless LAN. If we don't know how RF works, we can't make RF work the way we want it to. And so it's very important to understand these foundations. Therefore, even if you've been around Wi-Fi for a while, I'm sure you'll hear some tips and tricks that will help you better optimize your networks as well. Okay, so let's talk about our agenda for today and what we'll be talking about. First of all, we're going to be looking at RF basics. So before we get into the 5 RF fundamentals, I do want to review some basics with you to make sure you have the terminology down. Then we'll get into the 5 RF fundamentals, which are channels, behaviors, measurements, interference, and analysis. And we'll look at those one by one. Now, we also have relative power levels, and I'll talk about that in a moment. But first, some terms, RF measurements. We have this term called RSSI. It stands for Received Signal Strength Indicator, and it can be a bit complex because technically, according to the 802.11 standard, it's a value that different vendors end up specifying differently. And many tools today don't even say RSSI, they'll just say signal strength or something like that. And oftentimes they're reporting it in dBm instead of reporting it as some arbitrary value. So RSSI has kind of evolved over time, and today people will use the term in direct exchange for dBm. But technically, according to the standard, RSSI is not equal to dBm, and dBm is not equal to RSSI. But you'll see them used interchangeably a lot when people are talking about signal strength. Probably the better term to use is more generic signal strength, rather than saying RSSI, if you're going to equate it to dBm directly. Or you need some way to map what an RSSI is to a dBm. So sometimes the common vernacular can get a bit confusing out there, but for now just know that RSSI is a factor of your signal strength, and signal strength is often reported in dBm these days. The noise floor is just the signal strength of the RF noise in the frequency space that you're using within that environment. Usually we're looking at somewhere between neg 93 to neg 103 or 104 dBm. And that would be your noise floor. The difference between the received signal strength and the noise floor is what we call SNR, and we represent it in decibels, dB. So if the noise floor, for example, is neg 95 dBm, and the signal strength is neg 70 dBm, then that means your SNR is 25 dB, not dBm. It's 25 dB. There's 25 decibels difference between the signal and the noise floor, okay? So we want to use the right term, dBm, the signal strength, dBm, the noise floor, but SNR is just dB, okay? So this is a relative value because it's the difference between two absolute values. So it's going to change depending on what the two absolute values